Hello, everybody. Okay, first thing I want to say is I don't know about on your dynamo case, but I can freely rotate this upper cap on the. It doesn't have a notch. Is what I'm trying to. It only have a built-in notch here and also on this lower part. It's got a little notch here. So it'll be convenient for you to mark it, okay, because you can turn this around 180 degrees and have the everything changes here. So it is very good to mark it, and as the same token, it gives you the perfect alignment to run these bolts through there. Um, okay, I also mark this the front cap with the pulley is on. And I want to go over this armature real quick. Uh, Carl Sifta was perfectly right. Every commutator element has a wire attached to it. That means all 28 elements are wired to the armature windings. So, anyways, that out of the way, that clear. Let me remove the cap and take a look at my inner stators. Okay, so here is where the positive is, and I have the stators right there, and you can see that I have a small issue right here. There's no room to add a third stator here. Not at all. So this will become a long-term project here because I'm gonna have to take the stators off and try to see a way of modifying them or getting a smaller ones. All three, and from another machine, of course. Anyways, I have the stators attached as conventional. They go negative to ground, positive to the isolated terminal. And I'm gonna add some power to this. I'm gonna go a little higher than before, about 5 volts. Otherwise, the tool will be able to detect the the polarity. Okay, so this is the north right here. Okay, which is right here next to the positive terminal. And on the other side, let me get this right because I'm doing it with one hand. This is the south. So this is the south, which is identified by this bolt, and this is the north right here. So based on this and the way the brushes are set on this machine, which is the brushes are set like this, so we have a positive brush. Again, the other one, we don't have anything. It's grounded directly inside. This is the positive brush, and according to the way it's set, it'll give us the armature winding magnetic polarity on the armature based on this brush arrangement, which are 180 degrees across, and the stators are right here. So I'll make a cut drawing of the original the way the Ford dynamo is set. Okay, the other thing that later on I'm gonna go over, it's the fact that this type of winding comprehends 5 of these poles, of these core elements. Okay, each winding. So you can see where it dies. It dies right here, like following this one, and This 1, 2, 3, 4, and 5. Okay, so it gets 5 elements. I'm sorry, 6 elements. It gets 6 elements each winding. Now, this has to do with the propagation of the field within the armature. The more you overlap these, the more the width of these windings have to do a lot with the size, the side of the armature that is magnetized. Okay, and so they overlap. There is an overlapping, magnetic overlapping, because they cross in reference to the way that we input power on the commutator. And this has happened to me when I was trying to build a rotary generator, a virtual magnetic field rotary generator. It's a problem we have, and that's why I had to reduce the angle of the rotating commutator I had, so I can reduce this to the minimum, and that's how I got more gain. But then again, this is another issue right here that we have to correct. Now, if the windings will be comprehending less poles, it'll be more precise, the magnetic fields on both sides, north and south, because when we put positive and negative here, we create a north in half of the armature and a south on the other half, no matter if it rotates. Okay, these fields stay stationary. Okay, what rotates is the core, the wires, the coils in turn, but the brushes are fixed. So the field is fixed. And what makes it the rotation is that the coils try to keep on aligning with the stators, and the stators are fixed, and this is fixed. And we went over. I went over this on my topic about the torsion fields, and this is basically a tool that you need to know in order to know how these machines work in depth. I don't mean to go slightly showing with just one, square conductor turning around a field. That doesn't help you at all. This is the real thing. This is how you learn. Okay, so anyways, I already have marked my stators, and I know where to go from here. Okay, thanks.